Hi, in this video I am going to explain the basic use case of the NLP and what is the important terminology, word embedding, then what is the one of the famous algorithm, Word2Vec, and the one important Python library, the Gensims. So in this video, if you are the new for the NLP or just you want to develop something based out of the NLP, then this video is perfectly fine for you, because in the short video I am going to explain the very important terminology for the NLP, natural language processing, and half of the video I will show everything through the Python code. So please I recommend watch the full videos to get all the basic ideas, and I'm pretty much sure after watching the complete videos you will have very good understanding for the NLP and all those terminology. And one request, please don't forget to subscribe this channel and like the videos, because a lot of effort is going to make on videos here, right? So as you know, the natural language processing, what is the basic use case? So these are the some of the important use case of the NLP. One is the speech recognition, right? So today if you see the home automation, very famous thing is the Alexa or the Google, right? So if you can say switch off the TV, switch on the TV, how the Alexa, how the instrument is going to understand your voice and then converting your voice into execution of the some orders, right? So behind that NLP is there. Text prediction. Nowadays you have already observed when writing the email, particularly in the Gmail, if you write some sentence, after that they start predicting some words. So you no need to write, you can just put the enter and the predicted sentence words make your sentence complete, right? And the text classification. So if you go any news channel and they divide or categorize the news in the different category, right? So you have some politics news, sports news, world news, finance news, how they used to do that. So behind that we have the text classification that also we can achieve through the NLP. Questioning answers, right? Many websites implement the chatbot. If you give some questions, they will give the answer. So how those chatbot understanding your questions, even you write your questions in the different many other ways, right? So that is also the one of the NLP use case. Semantic analysis, right? So nowadays very famous to know the review. Even if you go to purchase some product on the Amazon or any website, you want to see the review, right? So how we analyze the review, whether this is negative review or the positive review, all those things come under the NLP. But if you see that for all the use case, what is the input in the system? The input in the system is the text. Even for the speech recognition, your speech convert into the text, right? And everything is the text. And then you put this text into some machine learning model or deep learning model that will take the text input and they will give the output as a predictions or whatever you want to achieve. But we know the machine learning model can only understand the numbers. They cannot understand your text. So you cannot pass as a text into the machine learning model. So for that what you have to do means some system should be there where you can pass this text, and this system can convert your text into the numerical representation, and then that numerical representation you can pass into the machine learning model. That model, then this model will work as it is used to be work when you passing the numerical representations. So the important thing, what is that thing that we convert your text into the numerical representation? And that system is called the word embedding. So word embedding, actually that is the mathematical representations of the word that captures is the semantic and the syntactical meaning of a word in the given of the corpus and the given the context. So suppose if you give the one word apple, orange, man, king, queen, they will convert into the numerical format, and that is actually a vector. That I will show you in the code also, and I will explain you in detail also. So if you see what is the word embedding? Word embedding is a vector space that contains the meaning of a word depend upon the given context. It preserves the relationship between the two words. So if there are the many words in the corpus, what is the connection of the one word to the another word that maintain the relationship? What is the connection of those things that can be preserved by the word embedding, right? The capture the similarities. Suppose if you given the one word and find out what are the similar words in this corpus, that also you can find out. So this is very important if you want to do anything in the NLP, because it will convert, word embedding will convert the text into the numerical representation. Then you can use this numerical representation for the inside any model, and you can find out or the execute any of the use case, right? So why the word embedding? It is very simple. So why you cannot give one ID for each word? So suppose if you see the English dictionary, so suppose I have the 50,000 words in the dictionary. So you can give the number. So suppose I will give the one number man, two number apple, three number anything sports. Suppose 156 is the orange, 9,860 is the woman, 10,950 is the king. It will not work. Why it will not work? Because then if you see the apple number you have given 2 and the orange you have given the 156, but you know some connection is there between the apple and orange, but numbers are the too far. You cannot make any meaning of that, right? If you do the similarities, there is no similarities if you talk about the numbers. The same way if you see the man, king, woman, these are the human being, but their ID is very different. So this thing will not work. So that's why this word embedding come in the picture, that they can reserve or they can preserve the meaning of a word particular for the given context. So let me give one more example. So if you see this sentence, if you see the I learn Python, and another sentence, today I saw a Python. Python, what is the same here? Here is also Python, here is also Python, but the meaning is different, right? This sentence Python means the programming language, and this sentence Python is a very big snack, right? So in this case, if you give the ranking for the number 1, 2, 3, 4, that system will not understand what you are saying. But if you make the word embedding for this Python, you will get the different representation, and for this Python it will give the different representation, because they will consider the whole corpus to making the embedding for particular words. So that's why word embedding is very important. We will see in the code why it is important. Now if you see, there are the many different kind of the embedding, right? One is the frequency based word embedding, and second is the prediction based word embedding. So in the frequency based, that we count the particular word in a given sentence or in the different document to find out the text classifications, right? So these are the different techniques by which you can do the frequency based word embedding. One is the counter vector, second is the co-occurrence vector, third is the TF-IDF, and the main use case of the frequency based word embedding is the text classification, text summarizations, and the semantic analysis. If you see these are the things main use case for this one. And if you see the prediction based word embedding, they will try to capture the context. Means if you given the sentence here, if you given the sentence, from this sentence they want to know what is the purpose for the Python here and what is the purpose for the Python here. So they are trying to capture the context, what is the meaning of that, and they predict the next word as I explained earlier, and what is the similarities and the similar words. So if I given the one corpus, and among that corpus if I say one word, suppose man, or the king. What are the different similarities words are there in that corpus, that also we can find out through the prediction based. So there are the many algorithms by which we can do the prediction based things, and one is the very famous Word2Vec that we are going to see below, and the Word. But next video I am going to make on the Word, you can see that. And these are the use case for the prediction based word embedding, text prediction, search engine. So if you search in the Google, right, if you given some sentence, they can find out in which context you're asking something, right? So that search engines have used the prediction based word embedding, right? So if you see the prediction based word embedding, we have the different algorithm Word2Vec. So if you see here the Word2Vec, they have the different models inside the Word2Vec. One important model is called the SIBO, continuous bag of the words model, and another is the skip gram. So actually the SIBOs, what it will do that if you give some syntax or the text, they will predict the what is the target word from the given context. So if you see in this sentence, they will try to find out what is the target words. If you can see here, Python is the target words, right? So they will try to find out the what is the target words in the given corpus. In the opposite, if you see the skip gram, they will find out the different words from the target words. So we use different for use case, we use the different models, and as I said that Word2Vec is the popular algorithm who generate the word embeddings, right? So through the Word2Vec algorithm, we will generate the word embedding for the given corpus that you will see in the code. So the one is the this one, the Gensim. Gensim actually is the very famous Python libraries. Using the Gensim, we will execute all the algorithms. So we will use the Word2Vec and we will generate the word embeddings. So as I said that Gensim is the very famous open source Python library for the unsupervised modeling for the NLP. So that you are going to use that. And also when you go to the use the Word2Vec, so we have the two options to use that. Either you can use our own corpus, we will give our own corpus and do all the operations, or we can use some pre-trained model also, and then we can do all the operations. So everything you are going to see in the code. So again I will say, you complete whatever I am going to show in the code, you repeat the same thing, so you will have the good understanding on the complete Python code. First and foremost, we need our Gensim library, so we have to install it. I have already done, so it will not execute here, but in your case you have to do that. What I will do for this example, for this demo, so take one two simple syntax, right? This is a corpus, and then find out how to create the embeddings. So for that, what I have done that we create one model with the help of the Gensim, and also we took the cosine similarity that we can use to match the similarity whether one word is matching with the other words also not. So I have taken the two sentence here, right? The similar sentence for the dog and puppy. But you know, in the NLP, you have to pass the words inside the model. You should not pass the syntax, right? So that's why I convert this sentence. I took the each word, make it the split into the words, and make one list the word list. So if you run it, you can see all the words of this sentence has been broken down into the words. Once you do that, then now we can see the what is the embeddings value. So now we can find out the each words what is the word embedding. So let me paste this code here. What I did, I passed these words into the Word2Vec model that we have created right now here, right? And then pass this list of the words, and then we can check what is the puppy embedding and what is the dog embedding. So very nice. If you see here, this is the the word embedding vectors, space vectors for the puppy. See, use data that have taken the almost 100 dimensions, right? So actually the corpus is not strong, that is 100 things. But if you see if you take the bigger data, you can see the bigger corpus, the dimension is going to increase. Let me see that how much dimensions we have. So if you see what is the first one, embedding one, go and see what is the size of this. So it is showing the 101. So that's why it is able to preserve the context and the meaning. They took all the properties of particular word from the corpus. That's why it is able to maintain everything, right? Now once you do that, now what I will do, I says that I took the embedding for the both, right? I took the embedding for the puppy and dog. Let me see is any similarities between these two embeddings, between these two words puppy and dog, because I have taken the sentence in such a way that it looks both should be the same, right? So I pass this both embedding 1 and embedding 2 inside the cosine similarity methods to find out that how much equalities are there. If you see, it is the 0.11, means cosine similarities vary from 1 to the minus 1 to the 1. Minus 1 is nothing matching, 1 is the high matching, and it is showing the almost 10% is matching, because our corpus is not too high, so that's why it is not showing. As I showed in the video that you can use the Word2Vec with pre-trained data also and with our corpus data also. So what the code I showed, this is our data in the corpus, right? This is our data. But now Google and their team has made one very good corpus, almost very big millions of data they have taken that. So that I am going to use here. And then you can see everything over there, almost most of data over there, so it will be easy to generate anything. So that name is the Word2Vec Google News 300. It's a pre-trained model, and that they have the 3 million words and the pages, right? So we are going to use this trained data model, pre-trained model. So how you can use that? So it's very easy. So you go, we have already installed the Gensim, so use the downloader API and see which model you want to download. So I want to download this pre-trained model and just run that. It will take some time because they have the use size, but just you have to wait for that, right? So if you want to start from the pre-trainings, then these 2 lines of code is sufficient. No need to do anything what I have showed over here, right? So I showed using my own corpus text, but here you can use the pre-trained model. Once this execution done, you can see, and just I want to see what is the word embedding of for the dog, right, according to this corpus. And if you see just dog, so they generate this much big corpus, the word embedding for the dog. See, and if you see the how many dimensions are there, you can see this is almost 300 dimensions are there, right? The same way we can generate for the puppy also, and then we will see that what is the cosine similarity for both, right? So when we check with our data, it was coming 1.1, 0.1. Now if you see with this shape of this one, you can see 0.8 is coming, because they preserve many more context informations, because they have the predefined use corpus things, right? So now we can see the similar kind of things. Suppose if I want to see what is the embedding for the king, right? So go model and put the king. This is embedding for the king, right? Why I'm doing for the king? Because we have the one, if you want to know the what is the similar data, similar words, as I explained on the whiteboard. If you want to know what are the similar words compared to the king, so you can see that, right? So that the similar word for the king, so you can see the kings, queen, monarchs, crown princess, these things should become, because these are the similar word for the king. How they are able to give the similar word? With the help of the word embedding, right? So those words also have the similar things, and this will also show you how much similarities are there. So just wait for that. So if you can see, it generates the similar words for the king, and suppose this is the queen, so the similarity is kings. You can see how much similarities are there. This is the way we can take the advantage of the word embedding. Let me show something very interesting. So I'm going to take the word embedding for the king, man, woman, and take also the for queen. And one very famous one example is there. One embedding means if you can do the king minus man plus woman, what should be there? Because if it is a king, right, king have the many properties, right? And if you remove the main properties from the king, it becomes the kingdom kind of things, right? The variety and all those things you can that they preserve. And then on that properties, if you add the woman, that should become the queens. So after execute that, let me check that whether the queen and king is similar or not, means the result and the queen is similar or not. So according to our analysis, the queen, what is the queen word embedding and this result embedding should be the same. So let me check the result embedding and the queen embedding, how much similar are there. And if you see it is a 0.73, means it is the similar, right? So that's why I can prove that word embedding preserve the many more things. The same thing what I will do the calculations here, you can do the same thing with a different API call. So you can do that model dot most similar, and then you can pass all the positive things. Positive means here king is the plus sign, woman is the plus sign. So pass the king and woman, and what you want to subtract, I want to subtract man. Then tell me after I add up from king, if I add subtract the man and add the woman, what are the similarities things should become, because I know it is the queen. And then you can see queen is the one of the result, and also with the queen what are the different results are there, right? So then you can see that here is the queen, princess, queens, sultan, monarchy, all those things is coming, right? So this is the one thing. And one important thing also I want to show, because this is the one we took the trend, right? Pre-trend model. If I have my own twin corpus, so suppose I have given these words, right? The quick fox jump over the veggie dogs, right? This is my own corpus. And then if I want to see what is the similar word of the king, so then how it works, see that it should show the his also, right? Yeah, his, boy, man. So it's working fine, right? So these are the important things I want to show here in the demo. So I think I have already I successfully explained what is the use case of the NLP, then what is the word embedding, what is the Word2Vec, then what is the different algorithms for the Word2Vec, then what is Gensims, and what is the similarities words in all those things, right? In the next video I will come with the many more things for the NLP. Thank you very much, but don't forget to subscribe to the channel. A lot of effort is going behind that. Thank you.